one of the problems with pore pressure prediction and estimates is that we can only measure pore pressure where we cannot predict it. And we can only predict pore pressure where we cannot measure it.
Say that one more time.
Yeah,
So,
my brain's going.
yeah.
My brain's going one more
So
time.
we can only measure pore pressure where we cannot predict it. So we measure pore pressure in permeable units, sands, carbonates, but we cannot predict it in those units. And we can only predict pore pressure where we cannot
Can't
measure
measure
it. So we can only predict pore pressures in shales.
Okay.
So the final pore pressure profile we built is really a combination of that prediction and the measurements.
Fascinating. Okay.
And this here is a conventional approach for pore pressure prediction. So what you see in that plot there is some sonic data plotted against depth.
Okay.
And what we've done is we've generated what is called a normal compaction trend, which is the red profile here.
And now is that compaction trend lithology dependent or independent?
Or it is because all shale, depending on clay content, will have a slightly different compaction trend.
Okay.
Yeah.
So that compaction, but remember when we're talking about prediction, it's shales we're talking about,
Yep.
right? Yeah. So this normal compaction trend here, that's sort of the conventional approach we apply in order to predict pore pressure, in our areas or wells. So what we can see is we derived a normal compaction trend here, describing the expected compaction of our shale rocks. And then at this step here, about 2,000 meters, you can see there's a deviation from the trend.
So once you hit around 6,000 feet,
Yes, in this
then
case here, around
in this case, yeah.
Yeah, thanks, Gabby. So around 6,000 feet or 2,000 meters, we can see that there is a separation from the trend there, which indicates or could indicate that we got overpressure setting in at that approximate depth there. Now, it doesn't have to be overpressure. It could be that the composition of our shales has just changed. So instead of having this initial loading curve here, we just have a different loading curve. But in order for this conventional approach to work, we assume that this deviation from our normal compaction trend is due to porosity preservation, and porosity preservation is an indicator of overpressure.